Okay, so today we're going to learn how to write formulas for binary ionic compounds. What does binary mean? Two. Okay. So when we're looking at binary ionic compounds, it's just an ionic compound that's made up of two elements. Okay. And when it's ionic, what kind of elements are in that compound? Okay, it's almost always going to be a metal plus a nonmetal. There are like rare exceptions, and those rare exceptions come from the polyatomic ion chart. Okay, but so it's just two elements. One's a metal, one's a nonmetal. Okay. Now one thing to keep in mind: ionic compounds are electrically neutral. Remember, think about if you touch your table salt, do you get shocked? Yes. No, right? They are neutral. So that means as we write formulas, the charges are going to have to cancel. And I'm going to show you how we do that, okay? But when I say charges must cancel, that means your number of plus charges has to be equal to your number of negative charges. Okay, I have steps on how to write the formulas. You don't need to write these down if you don't want to. We're going to do plenty of examples of like following these steps, but they are here for you if you need them, okay? So when we write formulas for ionic compounds, we first just start by writing the symbol and the charge for each ion. Okay. Then ionic compounds are neutral, so we have to balance those charges. We balance those charges doing something that I just call the crisscross rule. And then finally, we reduce subscripts if needed, and I'll show you what that looks like. Okay. So these are the steps. You don't have to write these down. We're going to do a couple examples together. We're going to follow these steps. All right, so the first example, we're going to combine potassium and chlorine, and we're going to end up making potassium chloride. Okay. When we write ionic compounds, the cation always comes first, always, always, always. Okay, and when you're given the name always puts it first also. Okay, so the cation is potassium. So the first thing you have to do is look up the symbol. So what's the symbol for potassium? K. All right. What is the oxidation number for potassium, or what charge will it get if it becomes an ion? Plus one. Okay. I'm going to write the 1 for now. Do you always have to write a 1 up there? No. You don't, but for today I'm going to write the 1s because I want you to be able to track the numbers. Okay. Chlorine is going to turn into chloride because we're doing ions. Okay. What's the symbol for chlorine? Okay. And what kind of charge, or what's the oxidation number for chloride? Okay, it's that 1 minus. Okay, so this is step 1. You do the symbols and you do the charges. Okay. Then we have to balance the charges. This one is an easy one because does that 1 positive charge balance the 1 negative? Okay, it does, but they're not always as simple. So to balance them, we have this like crisscross technique that balances it for you. So you're going to take the number only, not the charges. This superscript comes down and becomes the subscript for chlorine. Okay. And then this superscript comes down and becomes a subscript. Okay. So it becomes K1 Cl1. Okay. No charges though, okay? Numbers only. Can you have a -1 subscript? Okay, so charges don't make sense for subscripts. And then finally, when you have a 1 as your subscript, you have to write it. Okay, so we don't typically write the 1. So we would just write this as KCl. Okay. So potassium chloride's formula is KCl. Okay, first we have calcium bromide. So we're going to start with just symbols and charges. What's the symbol for calcium? Okay. What is the oxidation number, or what charge would calcium get? Okay, that +2. What is the symbol for bromide? Okay, Br, and what charge does it get? Okay, when I say charge and oxidation number, are we talking about the same thing? Yes. Okay, so just make sure you're familiar with both. Okay, so ionic compounds have to be neutral. So right now, if we just did CABR, are those electrically neutral? No. No, right? We have a +2 charge and a -1. So that crisscross rule is our technique to make them neutral. So again, for that crisscross rule, you take the number only and you bring it down as a subscript. Okay. Then I take the number only, I bring it down as the subscript. So we end up with CA1 BR2. Okay. Once you get to this step, no charges. Okay, we're not writing charges anymore. And then last, do we have to write a 1? Okay, so I'm just going to rewrite it as CABR. Okay, so our final formula is CABR2. Okay.
Do you just take the bigger number? Put right there?
Nope. The ones, you just don't have to write the ones. Like a 1 is always implied no matter what. So you can just omit the 1. Okay. Any other number you have to include. Okay. Okay, this is all I want from you. I just want the formula. However, I just want to show you how to track charges because they have to be neutral. What kind of charge does the calcium have? What charge does calcium have? Calcium has that +2 charge. Okay. What charge does the bromide have? Okay, it has -1. However, what is this little subscript telling you?
There's 2 of them.
Okay, there's 2 of them, so what's -1 times 2? Okay, so then, are we neutral?
Yeah.
Okay, so our +2 balances out our -2. Okay, you don't have to write that. I just want to make sure you know how to track those charges and you know how to make sure you're neutral. Okay. Okay, let's do iron 3 oxide. What is the symbol for iron? Okay, iron is Fe. What does that 3 in parentheses tell you? Okay, that's telling you the charge of iron because iron's one of those transition metals. So that's telling you it's a +3 charge. How do I know it's a plus and not a negative?
Because metal is never negative.
Okay, metals are always positive, never negative. Next is oxide. What's the symbol? Okay, and what kind of charge? How many? Okay, it's a 2 negative. Do those charges balance? Okay, so what do you have to do? Crisscross. Everyone do it with your arms. You'll remember it. Crisscross. Okay, if it also helps to draw it, you can circle the 3, right? Circle it. I'm bringing the 3 down here. I'm going to circle the 2. I bring the 2 down here. Do you bring the charges with you? No. No charges for crisscross rule. Numbers only. So that leaves us with Fe2O3. Okay, are you with me so far? Okay, do our number of positive charges equal our negative charges for the iron 3 oxide? They should be. Okay, are you ready to try magnesium chloride?
Yeah.
Okay, what is magnesium? Okay, magnesium is Mg. And what's the oxidation number? Okay, +2. Where do I find that? How do I know that? Okay, it's just second column of the periodic table. Is it also on your cheat sheet?
Yes.
Oh yeah, it is. It's on your cheat sheet too. Okay. All right, what's the symbol for chloride? Okay, Cl. And what's the oxidation number? Okay, 1 minus. You can either memorize the column of the periodic table, or is it also on your little cheat sheet?
Yeah.
Okay, what's your next step?
Cross.
Okay, crisscross rule. Okay, what do you get for your formula? Okay, so you end up with Mg1Cl2. Do we write the ones? Okay, so I'm just going to rewrite it as MgCl2. Okay, I want you to try lithium oxide on your own. Give it a try. Words. Okay. What's the lithium symbol? What's its charge? Okay. What's oxide? What's the charge? Okay. What's your next step? Okay, so what do you get? Okay, and do you have to write the 1? Okay, so do you end up with Li2O? Good. Okay, I want to do one more example because I want to show you how to reduce subscripts. None of these were a good example for that. So I'm just going to make one up on the spot. So do one more example with me. Let's do tin for, let's do sulfide. Okay, so we're going to do one more. This one has like one more step at the end. Okay, so tin for sulfide. What is the symbol for tin? Okay, what is that 4 telling you? Okay, so it's got a positive 4 charge. What's the symbol for sulfide? Okay, and what's the charge? Okay. Okay, so what's your next step? Okay. We're going to crisscross. When you do the crisscross rule, what do you get for your formula? Okay, SN2S4. Are you with me so far?
Yeah.
Okay, this one has a new step. So my subscripts are 2 and 4. Is there a lowest common denominator between those two numbers? Okay, if you can reduce your subscripts, you have to reduce your subscripts. Okay, so what can you reduce this to? Okay, so the lowest common denominator is 2. So you can reduce it to SN1, S2. Do we write the 1? Okay, so the correct answer for this one is SNS2. Okay, so if your subscripts can reduce, do you have to reduce them? Yes.